Hello everyone, welcome to this course on Python for Economics from zero to economic data analysis. So this course has been designed specifically for students and professional from economics, management, policy study and social science related background. Therefore, you do not need to have a computer science student, you do not need any previous programming experience. Throughout this course, we will learn Python by applying it to familiar economic questions. So instead of using unrelated examples, we will work with variables such as GDP, inflation, unemployment, population, wage, export, import, and sectoral contribution. The purpose of this course is not simply to teach Python command. The larger objective is to help you to understand an economic question that can convert into structured data analysis process. So for example, suppose we want to compare economic performance of different states or countries, we first need to identify the appropriate indicators. We then need to collect data, inspect it, clean it, calculate the additional measures, create tables, and finally interpret the results. So Python helps us to perform all these stages systematically and producible. So we will begin with an absolute beginner level. So you'll first learn how to open Google Colab, run a simple Python command. We will then study variables, data type, operator, string, list, dictionary, conditions, loops and function. After developing this programming foundation, we will move towards the economic data analysis. You will learn how to import data, clean the dataset, calculate the indicators, construct visualizations, and conduct introductory statistical and regression analysis. So by end of the course, you should be able to develop a complete Google Colab notebook which is containing code, explanation, tables, chart, economic interpretations and many more. So the course should be followed in a sequence because each lesson builds on a concept that is introduced earlier. So you should also practice the code independently instead of using like watching the videos as well. So in this orientation section, I will first explain like who the course is intended for, what you will learn and what kind of final project you will going to complete. So let us begin by examining who can benefit from this course. See, this course is designed for a broad range of learners who want to use Python for economic and data related work. So the first target group is more profusely BSc Economics students. Many undergraduate economic programs now include quantitative methods, statistics, econometrics, and data analysis. However, student may not have the received formal programming training earlier. So this course will provide the required programming foundation gradually. Second target group is MSc Economics student. See, at postgraduate level, students frequently work with large dataset, regression model, time series analysis, and research project. So Python can help them to manage data more efficiently and make their analysis more reproducible. This course is also suitable for MBA students, particularly those studying business analytics, finance, research methodology, forecasting, market analytics, and economic policy. So researchers can use Python to reduce the repetitive work. For example, instead of manually applying the same calculation to hundreds of rows in Excel, a researcher can write Python instruction once and apply it to the complete dataset. The course may be useful for policy analysts who work with employment like inflation, poverty, development, education, health, or public finance. So Python can support preparation of indicators, comparisons, tables, visual evidences for policy report as well. Also, the faculty members can use this course to introduce the conceptual method into economic teaching, research supervision, and student project also. Most importantly, this course is intended for a complete beginner with a no coding experience. You do not need to know another programming language. You do not need to any kind of advanced computer knowledge. You do not need to understand machine learning before beginning this course. You only need the basic understanding of common economic ideas and elementary mathematical operations such as addition, subtraction, multiplication, division, and percentage change. During the course, every new programming term will be explained before it is used. We will work gradually and repeatedly practice important concepts. Therefore, even if the terms such as variable, function, loop, data frame are currently unfamiliar, that is not a specific problem. This concept will be clear through the practical example of economics. So the main expectation is that you should code along with the videos and complete exercises independently. Now, what will you learn? See, by end of this course, you will be able to complete major stages of beginner level economic data analysis using Python. So the first skill is importing economic data. Economic information may be available in CSV file, Excel worksheet, or other raw structured format. You will learn how to bring such data into Python environment. The second skill is cleaning and validating the dataset. Real dataset are rarely perfect. They may contain lot of missing values, duplicate observations, inconsistent country names, incorrect data types, or impossible values also. You will learn how to identify and address basic data quality problems efficiently. You will also learn how to calculate the economic indicators. For example, you may calculate GDP per capita by dividing GDP by population, calculate a growth rate using values from two periods, or calculate a trade balance by subtracting the import from export as well. So this course will teach you how to analyze data using Python. This includes selecting observation, filtering rows, comparing groups, calculating summary measures, and identifying patterns. You will learn to create table and visualizations. So a numerical result may be difficult to understand when viewed only as a raw data. Tables, line chart, bar chart, scatter plot, and other visualizations can make your economic patterns easier to communicate. So this course will introduce the basic statistical analysis. We will examine the measures such as mean, median, then maximum, minimum, standard deviation, and correlation. So towards the later part of this course, you will be introduced with the basic regression analysis. So regression basically allows us to examine how the economic variable is associated with another while recognizing the proper economic interpretations that require careful attention to assumptions. You will also learn to examine the economic trend over the specific time. This may include the changes in GDP growth, inflation, unemployment, and other economic indicators across the several years. However, producing a result is not enough. You must be able to interpret and communicate what the result exactly mean. So for that reason, every major activity will include economic interpretation. So you will be asked to explain the pattern, identify the limitation, and avoid making conclusions that are not supported by the data. The course therefore integrates the programming, data handling, statistics, and economic reasoning also. The final course outcome, this final promise of this course is that you will learn the enough Python independently, import the clean, analyze, visualize, and interpret the economic dataset. The word independently is important. Why? See, at the beginning of this course, you may require step by step instruction for every command. By end, you should be able to begin with the research question, organize your notebook, and perform a structured beginner level analysis. Your final capstone output will be complete Google Colab notebook. The notebook will begin with a clear economic question and description of the dataset as well. It will contain Python code, but it will also contain explanation written in the text cell. You will create a cleaned version of the original dataset. This means that you will be inspecting the raw data, identify relevant problem, and document the changes that are made during the cleaning process. You will generate the summary tables also. So this table may represent the average values, minimum, maximum observation, ranking or comparison between the states and countries over the year. Lastly, the capstone will include the basic correlation analysis. So correlation can help you to identify whether two variables tend to move together. Although we clearly discuss like why correlation does not automatically imply the caution as well. So you will also estimate the basic regression model. The objective will not be able to perform like advanced econometric at this specific stage. The objective will be to understand the basic process of specifying a variable, estimating a model, and interpreting its output carefully. Finally, you will provide a policy interpretation as well. This means that you will be move beyond the reporting numbers. You will explain what the results suggest, what the limitations are present, and what additional evidence would it be required for making a strong policy recommendation. Okay, and your final submission will therefore combine five major abilities: programming, data cleaning, statistical analysis, visualization, and economic interpretations. So this capstone will also prepare you for the next stage where you can study more advanced data analysis, econometrics, forecasting, machine learning, and AI based models. So let's begin with the economic question. See, a good economic analysis should always begin with a meaningful question rather than a programming command. So let me ask you, which Indian state demonstrate a stronger economic performance when the growth, per capita income, unemployment, and sectoral composition are considered together? So this question is useful because the economic performances cannot normally be evaluated using only one single indicator. For example, a state may record a high economic growth. However, if the unemployment is also high, the benefit of that specific growth may not be reaching all the sections of the population. Similarly, a state may have high per capita income, but its economy may depend heavily on one specific sector. So, this would create vulnerability that a sector experiences a specific major shock. Therefore, the question considers the several dimensions together. The first dimension is what? The economic growth, in which the growth indicates whether the economic output is expanding or contracting. Second dimension is per capita income. The per capita measures help adjust for difference in population and provide a basic indication of average economic resource per person. Third dimension is unemployment. The employment conditions are important because economic growth alone does not guarantee sufficient job creation. The fourth dimension is the sectoral composition. So we may examine the contribution of agriculture, industry, services to understand the structure of the state economy. See, Python does not answer these questions automatically. We must first decide like how the concepts will be measured, identify suitable variable, and obtain the reliable data. We must also decide whether the indicators should be compared using the original units or transform into a common scale or not. So this is going to illustrate an important principle. Programming supports economic analysis, but economic reasoning must guide the programming completely. So computer can perform calculations quickly, but the researchers must define the question, select the relevant indicators, and interpret the results responsibly. So throughout this course, we will repeatedly follow the sequence. Okay. So begin with the economic question, identify the required data, perform analysis, and interpret the finding. So this approach will prevent the course from becoming only the collection of Python commands completely. Okay. So over here, these slides provide you a preview of a type of completed analysis that you will eventually be able to produce. So see, this example is like economic performance analysis of Indian state. So just look at the process which begins with the raw economic data. The raw data may come from the government, publication, statistical agencies, international database, or research data set also. So before using data, we must examine its structure properly. We need to understand what each row represents, what each column measures, which year are covered, and which units have been used specifically. The next stage is data cleaning. So we may need to address the missing values, or we can say missing observation, duplicate records, inconsistent state names, or values stored in the incorrect format as well. After cleaning, we calculate the required indicators. For example, we calculate growth rate, per capita measures, sectoral shares, or composite indicators as well. We then generate summary statistics. So these statistics help us to understand the center, distribution, and range of data. So they can also reveal the unusual observation that requires the further investigation. The next stage is visualization. See, the chart always help us to compare the state and examine the pattern that may not be immediately visible in the large table. We may then calculate the correlation between the selected variable. For example, we might examine the state with higher per capita income that tend to have lower unemployment. However, this result will be needing what careful interpretation as well. See, a basic regression model can then be estimated to examine the relationship between the selected indicators. Regression provides more structured analytical framework, but its result depend on model design, data quality, and underlying assumptions as well. So the final stage is economic interpretation. So at this point, we ask the statistical result that actually mean. So we identify which state appears stronger across multiple dimension, which state display mixed performances, and which indicators require the further investigation. So this preview is not just intended to teach all the techniques immediately. Its purpose is show the destination of the course, and each part of the complete analysis will develop gradually through the separate lessons and exercise. So let's move to the next part, raw data to economic insight. See, in this slide, this represents the complete analytical journey from raw data to economic insight. Raw data by itself is not same as useful information. Imagine we download an Excel file containing economic indicators for several state and year. So the file may contain thousands of values, but looking at those values directly may not answer our research question. The first stage is to understand the data source. We need to know who collected the data, how variables are defined, which period is covered, and whether the values are comparable or not. Second stage is importing data into Python. This brings dataset into structured environment where it can be inspected and processed. Third stage is data validation. We check the number of rows and columns, examine the data type, and verify the expected variables at present. If we look at the fourth stage is data cleaning. We address missing values, duplicates, inconsistent labels, and invalid entries as well. The fifth stage is transformation. We may calculate new variables such as GDP per capita, growth percentage, trade openness, or sectoral shares. Sixth stage is analysis. We calculate descriptive statistic, compare the groups, and examine relationship between variable. The seventh stage is visualization. Chart provides us a clear way to display trends, ranking, differences, and distribution. The eighth stage is statistical modeling. So, depending upon the research question, this may involve correlation, regression, and other suitable technique. The final stage is interpretation. See, interpretation requires us to connect the statistical output with economic concept and institutional context. We should explain both findings and limitations, so the complete way can therefore be understood as what? Raw data, data cleaning, indicators, constructor, analysis, visualization, modeling, and interpretation. So Python help us to connect these stages within one reproducible notebook. This means that when data changes, we can rerun the notebook rather than manually repeating every calculation. So the objective of this course is to help you understand and perform this complete journey one stage at a time. Let's look at the next point now. What is Python? See, Python is a programming language A programming language basically allows us to provide instruction to computer in a structured form. For example, we can instruct computer to store GDP of a country, calculate growth rate, compare unemployment across the state or generate a chart. So one of the thing the Python allows us to do is to store the information. We can create variables for country name, year, population, GDP, inflation, or employment level as well. So Python can also perform calculations. So this calculation can be simple such as addition, subtraction, or more complex such as statistical estimation and forecasting. See, a Python can process dataset containing many rows and column. This is useful because the economic dataset may contain observations of thousands of household, firms, district, states, or countries. So Python can create table. So for example, we generate a summary table containing average inflation rate, minimum unemployment rate, or highest economic observation. So it can generate charts like line chart, bar chart, histogram, and scatter plot. So these charts help us to communicate the economic patterns very clearly. So Python can estimate statistical model with suitable libraries. We can calculate correlation, estimate regression model, and later perform more kind of advanced econometric and machine learning analysis. So Python is useful for automation as well. Suppose you receive an economic data set every month. So instead of manually repeating same calculations, you can write Python program that performs the complete analysis whenever the updated file is provided to you. Another important advantage is the Python has a large ecosystem of libraries. Libraries contain pre-developed function for specific task. For example, pandas panda is commonly used for data management, matplotlib for visualization, stats model for statistical modeling. So at this stage you do not need to memorize these libraries names or understand their complete functionality. The main point is that Python provides a flexible environment for moving from a basic calculation to a complete data analysis workflow. Coming to the last part, why economists use Python? See, economists use Python because modern economic analysis frequently involve large dataset, repeated calculation, and need for transparent and reproducible methods. One common task is importing CSV and Excel data. See, government agencies and international organizations frequently distribute economic data in these kind of formats. Python can also be used to work with the economic survey. Survey dataset may contain thousands or even millions of observations related to household, workers, firm or consumers. Economists use Python to calculate indicators such as growth rate, inflation rate, labor force participation, unemployment, poverty measure, and inequality measures. Python can support for wage and employment analysis also. For example, a researcher may compare wages across education level, occupation, industries, region, or demographic groups. So language can have be used to examine poverty and inequality. Researchers can organize the household data, calculate summary indicators, and investigate the difference across the population group. So Python makes it easier to compare states, countries because same analytical procedures can be applied consistently to multiple observation. Visualization is another important aspect or we can say application. Economic reports frequently contain lot of trends, chart, ranking, distribution and comparative diagram. So Python allows these visuals to be created directly from the underlying data. So economists also use Python to estimate regression model. So the regression is a central to many empirical studies because it allows researchers to examine the statistical relation between the variable. However, one of the Python most important advantages reproducibility. Means what? Suppose a dataset is updated with observations for a new year. In a manually prepared spreadsheet, several tables and charts may need to be updated individually. In Python, the same code can be often rerun using the dataset that is updated. So this reduces the repetitive work and creates the clear record of how the analysis was performed. So Python is not intended to replace the economic theory, but it is a tool that helps the economist to organize data, apply method, and communicate the evidences. The quality of final analysis still depends upon the research question, variable definition, data quality, assumptions, and also interpretations. So, uh, that's all for today for this course, for this particular topic. We will meet in the next session. Thank you.